In today's webinar, we'll be delving deeper into the topic of password policy myths and dead ends. And in this webinar, we will break down some of the most common misconceptions and see some of the new trends in password management today.
This time, we will talk about password policy myths. Yes, this is actually a pretty much lightweight set of topics if you compare that to the general secure coding things, like when we start talking about hard stuff like object-oriented programming and deserialization and what's wrong with XML parsers or injections and input validation. So this topic is pretty much a lightweight one. It's easy to conceive, but still I promise you lots of surprises, because this is a pretty much evolving arena, or a pretty much evolving landscape of the best practices that we have all around the password policies. Before we deep dive into the actual password policy set of topics related to the myths and the common misconceptions, and then of course about the best practices, let's have a couple of quick words about security in general, so that we get into the mood and somehow understand the biggest challenge about software security, about developing software with security in mind. So as a kind of introduction, let's see a little bit more about software security, what it is all about, how it behaves. And basically, when it comes to talking about security in the domain of software development, we can state a very simple thing. Software security is basically about bugs. Sorry, but that's the truth. It's all about the small mistakes developers make, commonly, which leads to exploits, leads to a possibility for the bad guys to exploit these bugs, these vulnerabilities, causing certain security incidents, breaking some of the security related requirements like confidentiality, integrity, and availability. So statement number one, security problems related to code are basically caused by bugs. Fact number two, unfortunately, there is no software without the bug, right? I suppose you know about the essential original Murphy's law of coding, which says that every non-trivial program has at least one variable, at least one branch, at least one loop, and at least one bug. Now, I pretty much like the extended version, which is here on the slide, which simply says each program has exactly 5 bugs, and unfortunately, this number does not depend on the number of the bugs found so far. So when you put these two things together, you arrive to a very aching, a very painful conclusion. Basically, there is no such thing as 100% security. There is no unhackable system. So you may even wonder at this moment, like, okay, but then why do we talk about something we cannot solve completely? And indeed, this is unfortunately the situation. Whenever we teach software security to software developers, which is basically teaching how not to code, as we like to say it, because developers already know how to code, and we teach them how not to. So we teach them all about all these nasty bugs and vulnerabilities. We start with this very harsh statement, very hard statement saying, sorry, whatever you do, at the end of the day, your code may be hacked still, because there are unknown unknowns, there are unknown best practices for the moment, which we don't know, that can lead to some things. This is a cat and mouse game. The bad guys evolve continuously. We have to evolve continuously to patch, to fix our mistakes and to fix our code so that it cannot be hacked easily. But whatever we do, unfortunately, we have learned this from the experience from the past like 30, 40 years. No matter what we do, they will hack our system. So it's more question of the motivation they have. And of course, it's question of how good your code is. So after this apocalyptic view of the whole software security, let me also have some good news. And the good news is about this 90% that you see on the slide. Basically, there is no such thing as 100% security, while the good news is that there is such a thing as 90% security. So what does this mean? So what is this 90% of security? If we follow the best practices, we can get rid of the 90%, we can get actually rid of 90% of the problems. And where does this 90% comes from? Gartner, Microsoft, antivirus companies, they all made analysis on their database of vulnerabilities. They did take a look at what is the root cause, what was the original bug, or what was the mistake which led to a broken assumption of the developer. What did the developer assume which was not true at the end of the day? And they figured out that actually 90% of the successful hacking incidents were results of certain problems in the code for which we already knew how to fix it. We already knew about the problem for long. So at the moment when the incident happened, we already could have known, and when I say we, I mean software developers, we could have known how to fix that problem, but simply those developers either didn't know about those best practices, or didn't know how to apply them, or didn't bother applying those best practices. So what this figure tells you is that basically, if you follow the best practices, you can get rid of 90% of the security incidents, and that is worthwhile doing actually. So that's the best we can do, but that is something we should do at the same time. And that remaining 10% will always be there. We have to understand this. And that's simply why I said that partially this is also a question of motivation of the bad guys, question of how juicy target our software application is, our service or product is, how much it is worthwhile hacking it. And the good thing about best practices, where our focus is when we teach software security to developers, is so the best thing. We focus obviously on teaching the best practices, and the best thing about them is that doing the best practices is kind of for free. Because basically, of course, you have to do investment. For example, sitting into a class where you hear about and learn about these skills and approaches in software security. But from that point of view, when as a developer you understand these things, it's simply the same coding done in the same amount of time. It's not an extra week you have to add to each developer, each development project. It's not an extra person in the group who should take care of security. That would never work like that. It's simply changing your mindset as a developer, opening your mind towards the fact that the code you write will be hacked and can be hacked by the bad guys. So it's all about paranoia at the end of the day, as I usually like to say, this is the nature of the game here. And if you look at it, also related to this statement, to this quote of Bruce Schneier. First of all, who is Bruce Schneier? He's a celebrity, if there is such a thing, like celebrity in software security. He writes blogs, speaks at conferences, and once he said that the goal here is not even 100 perfect security, which we just agreed that we cannot ever have, but rather adequate security. So the best we can do, and that best we can do, the maximum according to these numbers, is 90% at a reasonable cost. As I said, still there is a cost associated to this, but not necessarily a cost related to extra time in development projects. As I said, doing best practices is for free. If you look at this whole story from game theory point of view, however, it's also a very interesting situation. This is actually not a zero-sum game. Zero-sum games, when you gain something and somebody else loses the same amount. So there is a constant amount of points, tokens, credits, whatever in the game, and you can win or lose from each other. This is not a zero-sum game. Software security is not more, but it's an infinite game. And as it is usually in infinite games, the goal is not to win or to lose or whatever. The goal is very simple: just stay in the game. And if you translate that to the development work you are doing, most probably, basically staying in the game means staying on the market, right? So develop a software which cannot be hacked easily. I mean, it can be hacked, as we just discussed this, but cannot be hacked easily. Because then you will stay on the market, you will stay in the game. So the worst thing that can happen as a consequence of a security incident is basically loss of reputation. So of course you have GDPR, you have to pay fines if somebody steals some customer data or user data from you, and that's a direct cost. But that's nothing compared to the cost of losing reputation on the market. Because if you get into the news continuously saying, hey, if somebody hacked your system, they hacked your system again and again and again, then slowly but surely this will nicely eat up your reputation, and you will, well, go out of the game. So this single slide is simply here to get into the mood, to understand software security in more details. And as I said, this time we will actually discuss a pretty much lightweight set of topics related to secure coding. So we will not even see too much of code in this webinar. We will talk about password myths, more specifically password policy related myths. We will first talk about 4 myths. Like, you may think this is like that, but it's actually like this. And then I will talk about the best practices specifically related to password policies. Myth number 1, enforcing composition rules forces passwords to be stronger. Well, actually, this is true, but is it true for all kinds of passwords? Can we really ensure this unambiguously and strongly? So, you know, password policies, when you hear password policy, you simply think about right away. When you close your eyes and imagine a password policy, you will see the $sign, you will see digits, you will see capital letters, right? So this is our mental representation. And I promise you here some surprises later on in the best practices domain. Obviously, when we apply a strong password policy, it will make the passwords to be brute force much harder, because the biggest enemy here is, of course, brute forcing. So we have levels here, like guessing the password and doing dictionary attack against the password. And if nothing else works, then brute forcing is still there for the bad guys to do. And it's all question of processing power. If they have enough processing power, then the time needed to do the brute forcing can get from like hundreds of years to minutes, even seconds. Why not? It's all question of processing power. So bottom line is, reality is that users will not actually have stronger passwords necessarily. They may, but not necessarily. For example, this well-known P at $SW0RD1 exclamation mark, or any kind of disturbance, but still disturbance to a word that a human can remember. Because we are talking here about passwords, which is knowledge-based authentication. Obviously, this will pass any kind of password or some kinds of password policies, because it complies. It has a digit, it has even 2 digits, it has non-alphanumeric characters, capital letters, so it pretty much looks good, but still, obviously, this is a very weak password. So password policy seems to be okay and seems to be adding to security, but question is whether that is enough or not. And just to repeat once again here, I promise you certain surprises. So as I said, usually when we talk about password policies, we have all kinds of prescriptions here, and we even have certain best practices. But as you can see, in all these best practices, there is something which is the most important thing and which pops up everywhere, and that is the length of the password. Just to run a little bit ahead and kill the punchline related to the best practices. Okay, so myth number 1, composition rules, they're good, but are they good enough? And actually, are we paying too high price for them? That will be the most important question, as we'll discuss that. Myth number 2, having to change the password regularly also adds to security at the end of the day. It has been a practice for long that systems prescribe you to change your password every month or every 90 days or every half a year or every year, it all depends. So this has been part of security policies for long, actually not that much anymore. And this is, again, a new development, a changing landscape, as I said. So obviously, the problem here is that if you have to, so why did they make you to change your password on a regular basis? Because they said breaking a password with a brute force, if it takes like 100 years, then we don't care. But if that 100 years can be shrank into like a couple of months, if they have enough processing power, because that's like processing power versus the time, this is the game here, then obviously if we make the user to pick a new password every like 90 days. That's good, because by the time they can break your password in 90 days or more, the password will be different anyway, so that adds to security. That was one of the drives, or one of the ideas behind introducing this password as a password policy, or as part of the security policies. But reality is that regular forced password changes degrade actually password security, because believe me, I know what you did. I know what you were doing when you were forced to do this. Everyone did that. I did that even. What usually happens is that you pick a password you can remember, and then you have to change it. So you introduce a counter. Let's say if you have to change it on a yearly basis, you introduce a counter, and for each and every year you increase that counter, and then you will have password 1, password 2, password 3, password 4, or password 20, 21, 22, 23. Everyone did that, really. I haven't ever met a person who really was able to remember a new password every month, or every 90 days, or every half a year. So that actually, at the end of the day, this decreases security, because this makes the passwords of yours somehow predictable. At least some parts of your password are predictable, so they have to brute force only the rest of it. Also, it's perfectly against psychological acceptability. Now, this term psychological acceptability is very important in this domain. Frequent password changes will make users to write down the password on a post-it and put it on the wall. And this is basically why we can say that a too strict password policy, you may feel that it pushes security up and up and up and up, but there is always a limit. And the limit is defined by psychology. It's simply that you users are human beings that cannot take too much of, complicated solutions, or they cannot remember a new password for all 20 or all 30 accounts that they use continuously. So just make a quick count. If you use 20 different services, which would make you to pick a new password each month, that means 240 passwords per year you have to remember. No way, right? Obviously, you can still use password managers and things like this, but actually, again, just as it was in case of the mixed character sets in the password, this irregular password change as a policy actually adds to security a little bit, but the price we have to pay on the psychological acceptability domain is simply too high for a little bit of gain from security point of view. So this is the game here. The gain in security versus the price we have to pay for it on psychological level. And this is why it actually, as I promised you, this is a changing landscape this year. This time, in these years, password policies are being changed and are evolving to something where we started to take into account this fact of psychological acceptability. Third myth, password hints and suggestions have a positive effect because you don't have to implement actually forgotten password functionality. You just make the user to remember a password. If they forget the password, you allow the user to type in into the database some kind of security question or security hint or suggestion about what your password is. Your usual, let's say the name of your pet, or the hospital in which you were born, or the city in which you were born, or something like this. And if you can answer this question, then you can change your password to something new because you forgot the old one. But just imagine, we have a good authentication with strong passwords and strong password policies and good password storage, like hashing the password, salting, peppering. These are all the things we actually discuss in a longer class, but we don't have time to discuss these very interesting things here related to password storage, how to store it, which hash algorithms to use, and so on and so on. So just imagine, we are doing the right thing in password management and password storage, but then we leave a small backdoor saying, okay, we do the right thing, we do the hard stuff there, but we allow the user to just type in the name of a pet, and then we let the user in, or let the user, possibly a malicious user, to change the password if they can just guess the name of our pet, the name of our kid, our favorite football team, the city where we were born, or something like this. So this is definitely a no-go. So this is pretty much obvious, maybe the most obvious of all these myths. This is not really adding to security. One notable story was the 2013 Adobe hack, where a huge amount of passwords, a database of a huge amount of accounts leaked out. Passwords were hashed, of course, and they were protected. But there were security questions, and actually, for a user called Mike1953, the security question was, my name and my birth year is my password. Then obviously you can guess that. Similarly to all those suggestions about what street did you grow up on, or the city where you were born, or name of your pet, name of your kid, name of your favorite car, type of your car. These all are basically backdoors to an otherwise good and nice password protection. So reality, this made the job of the attackers significantly easier, because they don't have to guess your password now. They just have to guess your car type or football team or whatever. So this is an easy one. And the fourth myth is actually restricting password selection in any way is bad for security. Now, this is an interesting thing, because this seems to be the opposite of myth number one, because in case of myth number one, we said we discussed whether we need or not, or whether that adds to security enough, a password policy, which means mixed character sets, capital letters, and so on and so on. The opposite of the question is, do we really need to restrict the user, or should we just allow the user to pick any password? Because that's good from a psychological acceptability point of view, because we can say, okay, we allow the user to pick a password which they can remember, and then we are good. We don't have to deal with too many problems. There will be less forgotten passwords. So we shouldn't actually restrict the user in picking a password. That's the other edge of this continuum of password storage. Obviously, this is not perfectly true as well, but there is some kind of truth in this. So lack of restriction lead to easily breakable passwords, obviously, because if you allow the user to pick a password like 1, 2, 3, 4, 5, 6, which is the most common passwords for years, you have even a Wikipedia page for like the most common bad passwords out there. Obviously, you shouldn't allow this. You shouldn't allow your users to just pick any passwords. You have to have some kind of metrics. You have to have a measurement on the passwords, and if the measurement says no, this is a weak password, you have to reject the password. So with all this, I didn't say that you don't need a password policy, but you have to be extremely cautious on what the password policy is actually. So this is a borderline case, just to show you that this is far from being an easy problem, because we do have certain password policies. We need to have certain password policies. We need to evaluate the password strength, but the big question is how we have to do it. So these were the 4 myths. Like, you may think this is like that, but actually this is like this. And of course, it's always disputable, and it's always a very good topic for an argument, like how we have to do it. And basically, this is how we arrive to the best practices related to password policies, how to manage passwords the right way, what would be the best approach in password policies. First of all, what is a password policy? Password policy, as a kind of definition, an enforced guide to choosing satisfactory passwords. So obviously, there should be a set of rules which tells this is a good password, this is a bad password. Obviously, we need more like some kind of metrics and a threshold, saying if the matrix is like this and it's above the threshold, then that password is good. Otherwise, the password is bad. Why do we need to introduce this threshold and this matrix? Because we have to ensure enough entropy, so enough randomness, so that it becomes harder to brute force the password, and of course to prevent users from picking some common words against dictionary attacks. As I said, there are 3 levels when they are breaking your passwords. They guess your password. They can actually just do a dictionary attack, like taking all Finnish, Swedish, German, English words, and then trying out which one would match the hash value which is stored there. So basically, dictionary attack is reality, and if nothing else works, then brute forcing is still there, which is, just to repeat once again, just question of processing power. So we need to reject or to accept passwords during the enrollment. So this is important, obviously. During the enrollment, we have to apply something like this. And of course, we have to give a feedback to the user saying, okay, your password is rejected because of, and then we have to explain why so that the user can correct themselves. And obviously, as I said, psychological acceptability is extremely important here. So we have to keep that in mind. And I think that all the changes in password policies and the best practices related to password policies are due to the fact that we basically have we are giving more and more importance to this principle of psychological acceptability, which I already explained you is about taking into account the fact that your users are human beings. There is a limit above which they cannot take too complicated solutions, they cannot remember too complicated passwords, they cannot remember too long passwords. So we have to find the right trade-off between security and usability, user experience, and psychological acceptability is obviously about this user experience. Unfortunately, security and usability are enemies. So as I said, as I'm showing you, like if you increase one, you usually decrease the other, as well as vice versa. So when you increase security, you lose user experience, or if you do a too fancy user experience, sometimes you lose security. And the question is, where is the optimum? Where is the right balance? So if you don't find the right balance, and if you say security above all, and we have to increase security and increase continuously have more and more secure systems, that's fine. But as I said, due to the user experience dropping always, there is a limit to security. And as I said, this limit is unfortunately defined by humans, by human behavior, by psychology. Because what happens if you prescribe a too harsh, a too strict password policy? People will either turn away from your system saying, this is too complicated, I'm not using this system, I simply can't remember such a password. Or what is the other problem is that they will write down the password on a piece of paper and they will put it on the wall saying, okay, I can't remember the password, but no problem, I'll put it here in front of me, and I will have it anytime I want, which basically means at some moment we cannot go over security, and moreover we all of a sudden drop in with security because we will have all these post-its on the wall with passwords, and that would be bad. So if the users can go around your solutions, you can be sure they will. And this is depicted here with this image where there is a gate in the middle, but no other enforcement is there. So people just don't care about this gate. They will just go around the gate and they will just make their way through. They just want to use the system at the end of the day. So we arrived actually to the core slide of this webinar, which is about a document published by NIST. First of all, who is NIST? NIST stands for National Institute of Standards and Technology. It's a US-based standard. Basically, that's the standardization body of the United States. But despite the fact that they are a US-based organization, de facto, they became a kind of standardization body worldwide because everyone listens to NIST, what NIST has to say about security in general, about cryptography, about all kinds of different security-related solutions. Well, the world listens to them. And actually, they have a living document called the Digital Identity Guidelines. The code is 863B. And specifically in this document, in section 511, they deal with password policies. And actually, as I said, this is a live document, regularly updated, so they make new versions of it. The last update happened actually in 2017. So the set of best practices here, at least according to NIST, but we cannot more than agree on what they have to say. This is perfectly aligned to our vision also on password policies. So the last update comes from 2017, so it's already 6 years old document. So the best practices you will learn about here are actually not even, something which is cutting edge and just was changed last year. No, this is still already a 6-year-old set of best practices. So let's see what they are. As I said, one and most important, the most important parameter related to password handling is basically the length. The password policies is the length. So that's the most important parameter you have to take into account when you want to measure the strength of a password. And since 2017, so the current best practice is actually 8 characters. So that's something which earlier was 6 characters, now still 6 digits is still enough if the password or the secret is generated by a computer, because computers are much better in generating entropy, if you like, and also they are short-lived things usually when we need something to be generated by a computer. But for passwords which have to be remembered by people, the best practice is 8 characters minimum. Do we have an upper limit? From security point of view, actually not. We shouldn't care about the upper limit. Password should be anyway hashed, and the hash is of fixed size. So once you have to store a hash value, you just don't care how long the password is. Still, from practical point of view, NIST says, well, if you really want to draw an upper limit for the password, like 64 characters would be something that makes sense. And of course, Unicode characters should be supported and appropriately validated. Obviously, as I said, the easiest way for a person to remember a password is if the password is in their own language. And many languages do fit into ASCII, like I suppose Finnish and Swedish may or may not, to be honest, I don't know, fit into the ASCII, but many languages do not. Just think about, Mandarin language. Obviously, they need Unicode, so Unicode should be supported with passwords. Passwords should be allowed to be picked in any language in the world, which means any writing, any font. So basically, Unicode support is essential here. So length, the most important thing. Password hints, we already had that as one of the myths. No way. So it's out of question. No password hints, password suggestions should exist in today's systems, which is still strange. For example, if you install Windows and you create a user on Windows operating system, still Windows or Microsoft actually implements a password hint. So if you mistype your password there in the Windows login screen, you can get a nice password reminder like, hey, your name and your birth year or something like this. But I would like to discourage you to do this, despite the fact that actually Microsoft still supports that. They shouldn't. Passwords hints and suggestions should be definitely banned from today's systems. And then the biggest surprise. So we arrive now to the core of the core slide. Password policy. What should be the rule to reject or to accept the password, besides, of course, the length that we already discussed? Accept or reject the passwords. And listen to me very carefully, because this is very important. Only based on a deny list, formerly known as blacklist. So a list of the bad passwords. So you can have a list of bad passwords to be rejected. This list can be statical, like really a database of passwords which leaked out elsewhere, and we know that there are bad passwords like 1234556 should be rejected, or 11111 or 22222. So or password as a password should be definitely rejected. This deny list can also be, of course, even dynamic, like repetitive characters, like any number of the same character, like AAA or AB, are definitely passwords which are weak. Dictionary words, as I said, you can just take the Finnish dictionary or the Swedish dictionary or the German or the Spanish or English dictionary and just ban all words from a dictionary, because these are common words anyone can try out. Context-specific words like a username should be also banned. Your password should not be used the same as your username, or even keyboard layout type of like QWERTY or ZXCVBN or something like this. These are all passwords that should be banned. And this is a deny list. And please read carefully once again. The only way to reject the password should be if the password is on a deny list, being static or dynamic. But what this doesn't say anymore, and this is the important and this is the surprising part, not even today, but ever since 2017, what NIST specifically discourages for you to do, is to use composition rules. Do you like the idea? I mean, everyone hated these composition rules, but actually the best practice is not anymore to use password policy as we knew it for long, namely prescribing capital letters and digits and non-alphanumeric characters, this is basically not part of the best practice anymore, as far as you are listening to NIST, of course. So no requiring mixed characters anymore. And this is great. So if you hated this all before, now you have a good argument for it. And the argument is called 863B. So if you run into an argument related to a password policy anytime in the future, now you have a good argument, say, look, this is not the best practice anymore. Even NIST prescribes not to do that, but just to use a deny list. And this is great. I mean, I'm really happy about this. And this is a tangible example for taking into account psychological acceptability. Why? Because earlier we added a little bit to security, but actually the price we had to pay with this mixed character set, but the price we had to pay on the psychological acceptability domain was simply too high. So we paid the high price in psychology for a little gain in password strength by prescribing all these kinds of things. So this is surprising, and this is a new, not so new development. As I said, a new development old 6 years ago already. So I like to say, like, in the old times, which still means today there are lots of systems which prescribe this, but they shouldn't. And then periodic expiration, also one of the myths that we had, no periodic expiration. NIST says clearly the only reason when you should enforce a password change with your users is if there was a breach. Then you already have a problem, but worsening the problem, you have to ask all of your users to change the passwords because you have been hacked and the password database has been stolen from you. No, definitely no periodic expiration. So again, maybe surprising, maybe not too much of surprise. When I think back, like most probably for years now, I'm not using any kind of service which makes me to change my password regularly, but still there are many systems that do this. And here actually it's also interesting, if any one of you work in the banking and finance and fintech, or you work with credit card numbers, you have to comply with PCI DSS. Even the latest PCI DSS 4.0, what's PCI DSS? A payment card industry's data security standard. It still, for example, goes against the NIST because they say 90 days, they prescribe 90 days periodic expiration of passwords. So we have a little bit of contradiction here between the two policies or suggestions or best practices. NIST says no, PCI DSS still says yes, and it's 90 days that can be extended to 1 year under certain circumstances. So as you can see from this, this is still evolving and still changing pretty much dynamically. Certain best practices tell you to do this, certain others still keep to the old procedures. But obviously things are changing. And then you have cryptographic requirements. I don't want to go into details here about that. And of course, user friendliness, like you have to support pasting because that's how all those password managers do in most cases. Also, you have to dot or star out the password as they type it against shoulder surfing when you may have a doubt that somebody's standing behind you. But of course, these days it also became a good practice from the user interface point of view to put a button there so that the user, if the user is absolutely sure that there is nobody behind them, they can click on a button to see where the typo was or what was wrong with the password they are typing in, how it's capital, its caps lock is set, or you have Finnish keyboard versus or Swedish keyboard versus US keyboard or whatever. So sometimes these things are confusing. So it's really good that nowadays you have a button to see the password being typed in. By default, you don't see it, but you have a chance. You have the opportunity to make it visible if you like. So as I said, we still need password policies, and we have seen the best practices on the previous slide. The strength of the password. So the most important thing about the strength of the password is the length. And of course, we have to apply a blacklist, a deny list, where we enlist statically or even prescribe dynamically what are those passwords that should be definitely rejected and all other passwords should be accepted. according to myth number 4, as I said, it was a borderline case. So we still need to reject passwords. We still need to assess the strength of the password, but it's definitely not, as you may think, it's not definitely not about all those mixed character sets and things like this. You can even have a tool, actually a library for this. One library we emphasize here is the ZXCB VBN. As you can see, it's a GitHub project, which is a nice library that you can use. Give it the password and it will tell you yes or no. So it will basically tell you the rejection or the acceptance of that. But as I said, it's a little bit tricky. We already said that the password policies as we know them are dead. So let's say that's P at $VORD, V0RD may satisfy actually all aspects of a password policy, even those old ones with the mixed character sets, but still are weak. And that was myth number 1. Well, password policy didn't solve all the problems here. And also sometimes we run into very surprising things, like just take a look at this GI32K7AU4A83. Actually, there was a breach and somebody figured out that this password has been used by many people. And they didn't know why. Like, what's so special with this character set? Like, why people keep using this password, statistically overrepresenting the occurrence of this? What's this? Because this perfectly may actually even slip through a password policy, the old one. It's long enough. It has digits. It has letters. Why people use this? And then somebody figured out that basically this character set string is basically how you type in on a Taiwanese keyboard layout these 4 Chinese characters, which represent in Mandarin, in Chinese, the my password. So this is how you type in my password in Chinese on a Taiwanese keyboard, JI32K, whatever. So this is how you type it. If you have a US keyboard, these are the letters corresponding to these characters in Chinese. So basically, this is tricky. And again, this is where the internationalization of password management comes into picture and shows you also why it is so challenging. What is also funny is that we can actually name the guy who invented the password policies, which we just buried in the previous slide, related to which we just said it's not really the best practice anymore. The guy is called Bill Burr. Bill Burr actually worked for NIST, and actually the original idea about password policies, mixed character set password policies, was introduced in the very same 863 document. In 2003. And even Bill Burr, who invented the whole stuff, a couple of years ago, when he gave an interview to Wall Street Journal, he said a very simple thing. Sorry. He said, never mind, forget about it. I regret. This was a bad idea. Just forget about password policies. I know I invented them, but no, I'm sorry. And of course, everyone was talking about, hey, even Bill Burr said $0 yen, like, sorry. So even he himself said, forget about it. It was a bad idea. So what is a best practice? And this is more for the user domain. Like, okay, length is the most important thing. And what as a user you can do is to, instead of passwords with all these mixed character sets, which are not necessary or should not be necessary anymore, you use passphrases. What is a passphrase? You basically think about 3 or 4, at least 4 words, and then you mix them together to a pretty long password. And it can be typically even longer than 20 characters. So it's a little bit longer, or it takes more time to type it in, but it's easy to remember because now you have to remember 4 terms. Visually, even you close your eyes and imagine a mountain, a frog, a door, I don't know, and a bicycle. And then that would be your password: mountain, frog, door, bicycle. You may know about XKCD already. XKCD is funny comics, basically a website that publishes these funny comics, and many of them actually deal with security and software development as well. And this is the famous correct horse battery staple, where they describe in this funny way, but still pretty much on spot, that if you have a password like troubadour &3 with the A and all the mixed character set stuff the old way, you basically get 28 bits of entropy. And that can be brute forced in 3 days if somebody can make 1,000 calculations of hash values per second. However, the correct horse battery staple, for example, these 4 words combined together produce 44 bits of entropy, and the time needed for that would be, with the same amount of processing power, 550 years. That makes a difference, like 3 days versus 550 years. Sorry. So obviously, the length is more important than any kind of disturbance. So shorter but disturbed passwords, and this is basically which makes it tangible why we have all these changes in password policies. Also, they say that because of this XKCD comics, the entropy of the correct horse battery staple password is basically 0. So just don't think about correct horse battery and staple. Think about, you know, mountain frog printer radio or whatever. Just make things up and make things up with words you can actually remember. And now it's time for a demonstration. For this demonstration, I will use our usual lab framework. As you can see, this is a Linux environment here, which we use for Java, for C, C++, and for Python. Secure coding training. For C#, we obviously use a Windows virtual machine. And in this Linux, in our real life classes, we distribute this virtual machine to the participants, and they have a pretty much real life environment with all the tools there. Like in this specific case, this is an example from Java. We have the IDE, which is IntelliJ IDEA for Java. You can log here in, download certain learning modules with all this source code, as you can see on the left side. What you see, however, on the right side is an essential part of our lab framework and teaching approach, which is basically the Cydrill attendant. It's a chatbot, pretty popular these days. It's not as intelligent as ChatGPT. Nevertheless, it's a chatbot, and it's a one-way chatbot that gives you instructions about what to do in the lab. So when you start a lab, it drops you certain messages, just like in, you know, Viber or Skype or any kind of chat system, telling you instructions. Let me zoom in a little bit so that you see. Open drill camp, log out if you are logged in, and take a look at the reset password. So that's the instruction. So let me start drill camp, and let me explain you what drill camp is, because now I started to drop in some brand names here. Like Cydrill attendant is the lab environment, as I said, in form of a chat. And drill camp is actually our famous website full of bugs. So we produce the website in Java. We have written this website in Java, in Python, in C# as well. And this website is, as you can see, running on localhost. So this is actually a browser, but it connects to a web application which runs locally. I didn't show you this here, but we are, of course, in case of Java, using Maven, deploy it. It's a local Maven running here in the virtual machine. And then through the browser, we hack this website through all these labs. On a typical 3-day class, we have some 30 labs, and the list, you can see some of the labs here. So let's get back to this demonstration. So this is drill camp. As you can see, this is a website. The cover story is booking.com or Airbnb. So with all these hotels you can choose from. Like this one, I think, is in the northern Sweden, just to show you, in Sundsvall. Yes. As you can see, we also have Google Maps integration, and there should be another one in Here is why. I think this is in Tampere, yes. So just to show you that we have some local hotels as well. Bottom line is, so this is a website full of bugs, and let's get back to the instruction of the Cydrill attendant. It says, try to find the reset password functionality, click on login screen. This is where I can log in, and here we have the reset my password. Once you do this step, as you can see, then the chat goes on and drops you the next instructions, saying something like, okay, thank you, take a note, this is how the password reset page looks like, and obviously it is far from the best practices that we discussed earlier. So you have to provide a username, like we have a user Charlie78, let's say, and the security question is simply the guardian. If you know the security question, you can change Charlie's password. But of course, we don't know what Charlie's first pet's name was. However, there are certain tools, and this is what this demonstration is all about. And this is why Cydrill attendant did open us a terminal. And in this terminal, we have to type in a quite long command line, starting the Hydra tool, which is for breaking passwords by bombarding a website with passwords which are either brute force or we can use a dictionary attack, which we will use this time. So and whenever you have a long command line you have to type in, then Cydrill attendant does you a favor and puts it on the clipboard. So let's analyze this command line that we have to start. So we are using the Hydra tool. The Hydra tool is there to, as I said, brute force websites. We are trying to crack Charlie's security question, like Charlie's password, but we are basically using this against a very weak security question, like we just have to guess the name of the pet. And then we have downloaded from the internet a cat and dog names txt, which is full of like typical names for dogs and cats. And we will start bombarding the website running on localhost 8080 with HTTP posting form to Cydrill reset password. As you can see, that's the path name for this page. And we will, in the username field of this post form, we will put the username Charlie, and the pet will be the first pet parameter, and that will be the password that this Hydra tool will start, getting from the cat and mouse dog names, and we'll try to break and we'll try to figure out what is the cat and dog name of Charlie. And we detect a success. Unsuccess trial is when we see security password is incorrect on the page. If this is not on the page, we know that we were able to hack this system. And it will not take more than a couple of seconds because Charlie's pet has a very common name. So let's see how this can be done. So I'm running the tool against the DrillCamp website, which runs locally on this virtual machine. Let's see what happens. I think I can count to 3, and that's it. We have it. So Charlie87 was the username we provided here, and password, but that basically the security question is Sally. So now we know that Charlie's name of the first pet security question is Sally, and we can do this in no time. Let me just show you this cat and dog database so that you see this is not magic. This is a simple list of all kinds of names. It's not even a long one. You can download from the internet much better ones. So these are the typical names you can actually use to not brute force but actually dictionary attack against this. And now we can put here Sally, and we can pick a new password like 123456. 123456, and with this we successfully changed the password. But anyway, as you can see on the right side, I already scored congratulations from the Cydrill attendant because it keeps track of what I'm doing. And once the goal of the lab is reached, it tells you, yes, super good, you are done, lab accomplished, congratulations. Okay, so this is really a simple demonstration. just to show you that even in case of password management, which, as I said, is a pretty much lightweight set of topics, but still full of surprises, we can have certain labs people can do in our courses to try out certain tools or to hack a website and then fix that very same website to see that the hacking incident is gone. And this is exactly our approach in when we discuss secure coding topics. And this is also the last slide. Time is already up. Not too much time for the questions, but I still would like to have the Q&A part. So bottom line is our approach is very simple. For each topic we discuss, like password policies, password management, input validation, injection, SQL injection, command injection, XML, external entity attack, whatever. We discuss usually things in 5 stages. First, we discuss the problem. Like, okay, this is what SQL injection is all about. Then we hack the website. So we have this mock website, the drill camp, and we try out certain hacking techniques. We don't want to turn people to the dark side, of course. We don't want to teach hacking. We just want to frighten developers, saying, okay, if your code stays like this, this is what will happen. And then, of course, the focus is on the best practices. So focus on the best practices, and then we even try out those best practices. We fix the source code of drill camp. We fix the source code in which we demonstrate the problem, and then we see that if the source code is written according to the best practices, the hacking technique does not work anymore. And then the last step is to present real-life case studies. So sometimes we bring in real-life case studies, like, have you heard about how SAP was hacked, how Google was hacked, how Ashley Madison was hacked, how PayPal has been hacked, because these are all stories where you can learn from other people's mistakes, and that's the best way of learning the best practices. So as you have seen, it's all entertaining and interactive with the Cydrill attendant and Cydrill sergeant keeping track of your job and what you have to do in the labs. We can have this as an instructor-led training, as well as we can have this in e-learning format, where obviously you don't have a trainer around, but still the Cydrill attendant can lead you through the lab and tell you what you can do. Where you can find the course catalog, tieturi.fi, Colutuxet, you see for Tieturi, and also for Informator, you can find the very same website at informator.se / you will find their secure coding courses. We cover C, C++, Java, C#, Python, already mentioned, among others. Some other programming languages here and there as well. We have several versions, like for web application developers, for desktop application developers, for developers versus for testers. So these are all like versions of these courses. And we also have certain vertical courses, like for healthcare, for banking and finance, for example, going into more details about this PCI DSS I mentioned. Automotive industry also have its specialities and special threats, and we even cover machine learning and AI hacking, which is a pretty new and emerging set of secure coding topics.